Hi everyone, this is Tutor Marife MCP. I create math tutorial videos that could serve as your supplemental learning resources. In this video, I'll be showing you how to solve this given system of linear inequalities in two variables by graphing. That means I am going to graph each of the inequalities and find the intersection region of all the solutions in the system. Recall that the graph of a linear inequality in two variables is a shaded half plane containing all the ordered pairs that satisfy the inequality. So when we say intersection region of all the solutions in the system, we refer to the intersection of the corresponding half planes. Note that the x and y coordinates of all the ordered pairs in the intersection region should satisfy both the inequalities in the system. Let's start with the first inequality in the given system. We have 3x plus y is greater than or equal to 3. For the first inequality, we should use a solid boundary line because the inequality symbol used is greater than or equal to. Recall that the boundary line is a solid line if the inequality symbol used is greater than or equal to or less than or equal to. The equation of the boundary line is the related equation when the inequality symbol used is replaced with an equal sign. So from the first inequality, 3x plus y is greater than or equal to 3, let's replace the inequality sign with an equal sign. We now have 3x plus y is equal to 3 as the equation of our boundary line. So we are going to graph this linear equation to divide the coordinate plane into two half planes. So how do we graph our boundary line 3x plus y equals 3? We can use any of the three basic methods in graphing a linear equation in two variables. The first method is by finding 2 points. How do we find 2 points? We can choose any values of x, then solve for the corresponding values of y. We plot the 2 points, then draw a line passing through the points. The second method is by using the y-intercept and slope. In this method, we are going to rewrite the linear equation into y equals mx plus b form or the slope-intercept form. And how do we write a linear equation in y equals mx plus b form? We should isolate the y on the left side of the equation. Collect all the other terms on the right side of the equation. The third method is by using the x and y intercepts. How do we solve for x-intercept? We set y to 0, then solve for the corresponding value of x. And how do we solve for y-intercept? We set x to 0, then solve for the corresponding value of y. Plot the two intercepts, then draw a line passing through them. I will be using the first method, which is finding 2 points, to graph the solid boundary line 3x plus y equals 3. Again, how to find 2 points? I can choose any values of x, then solve for the corresponding values of y. So for my first point, I'll be choosing x equals 0. And for my second point, I'll be choosing x equals 2. Remember that you can choose any values of x. Okay, so let's now solve for the corresponding values of y. If x is equal to 0, 3 times 0 plus y equals 3. Replace x with 0. Any number multiplied by 0 is always equal to 0. So we have y equals 3. This is the corresponding value of y when x is equal to 0. Therefore, our first point is at 0, 3. Okay, let's derive the second point. If x is equal to 2, let's solve for the corresponding y value. Replace x with 2. 3 times 2 plus y equals 3. 3 times 2 is equal to 6. 6 plus y equals 3. By subtraction property of equality, we can subtract 6 from both sides of the equation. Left side minus 6, right side minus 6. Cancel out opposite numbers. Y is isolated on the left side of the equation. The right side becomes the difference between 3 and 6. 3 minus 6 is equal to negative 3. Therefore, the corresponding y-coordinate of x equals 2 is negative 3. Our second point is at 2, negative 3. Let's now plot our 2 points and sketch our boundary line 3x plus y equals 3. Our first point is at 0, 3. Let's plot it. X coordinate is 0, y coordinate is 3. This is our first point. Our second point is at 2, negative 3. X coordinate is positive 2, y coordinate is negative 3. This is our second point. Now, let's draw a line passing through the 2 points. Remember that our boundary line is a solid line. This is our boundary line represented by the related equation 3x plus y equals 3. It divides the coordinate plane into 2 half planes. Next, let's determine which of the 2 half planes contains all the ordered pairs that satisfy the first inequality and shade it. To decide which one to shade, we are going to pick one test point. A test point could be any point not on the boundary line. The easiest and the best test point to work with is the origin or the intersection of the x and y axis. Why? Because the x and y coordinates of the origin are both 0. So we are going to plug 0 into x, 0 into y, and find out if we are going to end up with a true or false inequality statement. If we end up with a true inequality statement, then we are going to shade the half plane that contains the test point or the origin. If we will end up with a false inequality statement, then we are going to shade the other half plane, which does not contain the test point or the origin. So let's do it. Our first inequality is 3x plus y greater than or equal to 3. Our test point is the origin. The coordinates of the origin are both 0. Substitute x equals 0 and y equals 0 into the inequality. 3 times 0 plus 0 is greater than or equal to 3. Any number multiplied by 0 is always equal to 0. 0 plus 0, greater than or equal to 3. Of course, 0 plus 0 is always 0. 0 greater than or equal to 3 is a false inequality statement. This means we are going to shade the half plane that does not contain the test point or the origin. This is the half plane that does not contain the test point. All the ordered pairs in this plane, including the set of points along the solid boundary line, represent the solution set of the first inequality. Let's now consider the second inequality in the system. We have x plus 2y is less than 4. For the second inequality, we should use a dashed boundary line. Why? Because the inequality symbol used is less than. Remember that the boundary line is a dashed line if the given inequality symbol is less than or greater than. Obtain the related equation by replacing the inequality sign with an equal sign. So from x plus 2y is less than 4, we have x plus 2y equals 4 as the equation of our boundary line. So we are going to graph this linear equation. And we are going to use the same method, which is finding 2 points. To find 2 points, again, we can choose any values of x and then solve for the corresponding values of y. Again, I am going to choose x equals 0 and x equals 2. To solve for the corresponding value of y, let's substitute x equals 0 into x plus 2y equals 4. 0 plus 2y equals 4. Any number added to 0 is still equal to the number. So the left side is 2y equals 4. Let's use division property of equality. Divide both sides of the equation by the coefficient of y to isolate the y on the left side. Divide both sides by 2. Cancel out 2. Y equals 4 divided by 2 equals 2. Therefore, our first point has coordinates 0 and 2. If x is 0, y equals 2. Let's derive our second point. If x is equal to 2, let's replace x with 2. 2 plus 2y equals 4. Use subtraction property of equality. Subtract 2 from both sides of the equation. Left side minus 2, right side minus 2. Cancel out opposite numbers. Left side becomes 2y. Right side becomes the difference between 4 and 2. 4 minus 2 is equal to 2. Use division property of equality to isolate y on the left side of the equation. Divide both sides by 2. 2y divided by 2 equals 2 divided by 2. Cancel out 2. Therefore, y is equal to 1. We now have our second point. If x is equal to 2, y is equal to 1. After finding 2 points, we're now ready to plot them and sketch the boundary line. Remember that our boundary line is a dashed line. Okay, so let's plot the first point. We have x equals 0 and y equals 2. X equals 0, y equals positive 2. This is the first point. Our second point is at 2, 1. X is equal to positive 2, y is equal to positive 1. This is the second point of the boundary line. Now, we're going to draw a dashed line passing through these 2 points. This is the dashed boundary line of the second inequality in the system. After sketching the boundary line of the second inequality in the system, we need to decide which of the two half-planes contains the ordered pairs that satisfy the second inequality. So our options are this half-plane and this half-plane. Which one are we going to shade? Again, we're going to pick the origin as our test point. Why the origin? Because it is not on the boundary line. Okay? So, remember that the x and y coordinates of the origin are both 0. If these coordinates satisfy the second inequality, then we are going to shade this half-plane containing the origin. If these coordinates do not satisfy the second inequality, then we are going to shade the other half-plane. Okay? So, let's write our second inequality. We have x plus 2y is less than 4. X is 0, y is 0. These are the coordinates of the origin. So, replace x with 0, replace y with 0. 0 plus 2 times 0 is less than 4. Any number multiplied by 0 is always equal to 0. 0 plus 0 is equal to 0. 0 is less than 4. Is this a true or false inequality? 0 is less than 4 is a true inequality statement. That means we are going to shade the half-plane that contains our test point. This is the half-plane containing the origin. This shaded half-plane represents all the solutions to the second inequality. The dashed boundary line indicates that the set of points along the line are not solutions to the inequality. After graphing each of the inequality in the given system, we can now see the intersection region, which contains all the ordered pairs that satisfy both the inequalities in the system. The intersection region is where the red lines and the blue lines overlap. I'll show you the intersection region of the given system. This shaded region, including the points along this portion of the boundary line down to negative infinity, are solutions to the given system. How do we validate our intersection region? We could pick any point within the intersection region and substitute the x and y coordinates of that point into the x and y of each of the inequalities in the system and find out if both the inequalities are satisfied. So I picked this point. This point has coordinates 3, -2. +3, -2. Let's test the first inequality. 3x plus y is greater than or equal to 3. Replace x with 3, replace y with -2. So 3x becomes 3 times 3, y becomes -2. We now have 3 times 3 plus -2 greater than or equal to 3. Simplify the left side of the inequality. 3 times 3 is equal to 9 plus -2. Find the sum. 9 plus -2 is equal to +7. We end up with 7 is greater than or equal to 3. This is a true inequality. That means the coordinates of this point within the intersection region satisfy the first inequality in the system. Let's double check if these coordinates also satisfy the second inequality in the system. So our second inequality is x plus 2y is less than 4. Replace x with +3, replace y with -2. 3 plus 2 times -2 is less than 4. Simplify the left side of the inequality. 3 plus 2 times -2 is equal to -4. Find the sum. 3 plus -4 is equal to -1. We end up with -1 less than 4. Again, this is a true inequality statement. Therefore, the coordinates of this point within the intersection region also satisfies the second inequality in the system. So since both inequalities in the system are satisfied, then we can conclude that our intersection region is correct. This is the solution to the given system of inequalities. That's it. If you have any questions, use the comment section. Again, I am Tutor Marife MCP. Thank you for watching.